All right, now that we've got the folder put together, first thing I want to do is look at how do we find slope from all these different ways. The first one I want to look at is your graph, and then how to find slope from a table, how to find slope from ordered pairs, and from an equation. So let's look at the graph first. So when I look at this graph, and I look at this line going from uphill from left to right, or I start at the bottom and I'm going uphill, that tells me it's going to be a positive slope. So I know that. And then when I look at it, I look at my y-intercept, and then all I have to do is rise and run over to where the line is, and that way I know what my slope is. Again, as I go, I can rise and run, and then I can go down and over to where, in this case, I know I can rise 2 and run 1 and stay on that line. But the biggest thing I want you to see from here is that it's positive slope, seeing a visual of positive and negative. And this one, the reason I circled positive on this one is because this one happens to be a positive slope. So I went ahead and drew another line of what the negative slope would look like going downhill from left to right. That way I just always have a visual of, okay, am I dealing with a positive slope? Am I dealing with a negative slope? And that way you have that. Now on your table, on the table I've actually changed the numbers to make it a little bit more friendly than what it was. But what I want to do, look at the rate of change. We want to look at a couple different things. So when I look at this, the first thing I'm going to look at is, okay, with my y's, I'm just going to start there. Negative 2 to 4, well, my change is 6 plus 6. 4 to 10 plus 6. 10 to 16, I have plus 6. 16 to 22, again, it's plus 6. But then I look at my x's. I say, okay, negative 1 to 0, plus 1, 0 to 1, plus 1, 1 to 2, and 2 to 3. It's all plus 1. So I know I have a constant rate of change with my y's and a constant rate of change with my x's. So now, here's the question I posed in class the other day, is what's the relationship between the rate of change and slope? Well, if I look at how to do that, when I look at finding the rate of change, I'm going to look at, okay, my y divided by my x. My rate of change for my y was 6 divided by the rate of change for my x, which is 1. Well, 6 divided by 1 is 6. So in that case, my slope is going to be 6. Now, if I do it the other way, I can go with the formula of y2 minus y1. I just want to make sure that I look at the 2. Say, for example, here, I always pick the bottom one. It's just the easiest for me. But I'll say, okay, 22 minus 16, y2 minus y1 is 22 minus 16 divided by 3 minus 2. And that way it's going to tell me, well, 22 minus 16 is 6. 3 minus 2 is 1. My slope is going to be 6 over 1. So the relationship between rate of change and slope is it's the same thing. So if you can find the rate of change, you can find the slope. And from that, we can actually, you'll be able to write equations and see where a lot of what we've been doing, what we're going to do, how it works and how it goes together. Now, if I have ordered pairs, what I want to look at here is I have two different sets of ordered pairs, so let's look at them. First thing I'm going to do up here is I'm going to write the formula y2 minus y1 over x2 minus x1. Now let me make sense of all of this down here. So I have my coordinate pairs. And all I'm going to do, first thing I do is I label each number and what it is to get started. So I know everything in my first coordinate pair is going to be 1s. In other words, that's my x value and my y value of the first coordinate pair. So it's going to be x1 and y1. Then I look at my second coordinate pair that I'm looking at. Everything in it's going to be 2 because it's the second coordinate pair. So I have my x value being 5, my y being negative 6. So x1, y1, x2, y2. Now all I'm going to do really is just plug stuff in because I have y2 is negative 6 minus, well in this case I have a negative 3. So I have negative 6 minus a negative 3, which is really negative 6 plus 3, which gives me negative 3. Well, then I look at my x2 minus x1. Well, so x2 was the 5 minus the 2, and that gives me 3. So when I add that together, or when I subtract those, I get negative 3 divided by 3. Well, when I divide that, it comes out evenly as being negative 1. So my slope is going to be negative 1. The biggest thing that people get mixed up with is not getting the right x's and the y's. So remember, x1, y1, x2, y2. Now, on the last one with your equations, as if it's slope-intercept form, and I know we've been working a lot with that, because to find the slope with this in slope-intercept form, super easy. When you look at it, with your equations, y equals negative 2x plus 5. Well, I know that my slope, it's going to be the number next to the x. It's the negative 2. It's already there. Everything that's the m is your slope. Y equals mx, or y equals 1/4 x. Well, that m is my 1/4. That's my slope. And this last one, y equals just x. Well, we know that if it's just a variable, you have a number in front of it. It's understood to be there, which is 1. So I really have, if it makes you feel better to write this, y equals 1x. So then my slope is going to be basically 1. So then, and that's being able to find it from an equation. It's in slope-intercept form, being able to find it from coordinate pairs, being able to find the slope from a table, and the slope from a graph. So if you have any questions, I want to make sure you write it down, and we can talk about it in class tomorrow. Make sure you have everything filled out in class tomorrow, and that way we were able to get straight to the activities. And I'll see you tomorrow.